In this video, I'll discuss arithmetic of countable infinity RF0 and infinitesimal iota, which is 1 over RF0. We take it as a premise. If there is a one-to-one correspondence between the two sets, they have the same cardinality. This premise leads to the paradox that some part can have the same cardinality as the whole, but we accept this paradox in the theory of infinity. Thus, RF0 equals RF0 plus 1 equals RF0 plus RF0 equals RF0 multiplied by RF0, as you find in any textbooks. And as in video 4, we can prove RF0 equals RF0 plus n equals RF0 multiplied by n for any positive natural number n, and RF0 equals RF0 powered by n for any positive natural number n by induction. Thus, arithmetic of infinity is RF0 equals RF0 plus n equals RF0 multiplied by n equals RF0 powered by n for any positive natural number n. Before discussing subtracting infinity from infinity, I like to emphasize, as in video 4, even though Cantor considered RF0 to be the cardinality or size of the set of natural numbers n, and tried to evade as an element in the set of natural numbers n, because there is no infinite natural number, the fact that RF0 is a counting number cannot be eluded, because RF0 is the result of counting the number of elements in the set. Historically, the concept of counting numbers began with positive counting numbers. Then the concept of zero was added, and then negative numbers. And I would add countable infinity RF0 in these counting numbers, and also minus RF0. This is the response of AI to the question of subtracting infinity from infinity, which probably is the summary of current literature on this question. Even though the result is undefined or indeterminate, we can have a range of the result, which is between plus minus RF0, not just between 0 and 1, for example. Now, let's consider RF0 minus RF0. One example will be cardinality of natural numbers minus cardinality of natural numbers, which is RF0 minus RF0, and is like this, and is cardinality of null set, which is 0. Thus, in this example, RF0 minus RF0 is 0. What about this example? Cardinality of integers minus cardinality of natural numbers, which is again RF0 minus RF0, and is like this, and is cardinality of 0, minus 1, minus 2, minus 3, which is RF0. Thus, in this example, RF0 minus RF0 is RF0, and is like 2 RF0 minus RF0 equals RF0. What about this example? Cardinality of natural numbers minus cardinality of integers, which is again RF0 minus RF0. is like this, and is like minus cardinality of 0, minus 1, minus 2, minus 3, dot, 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 which is minus aleph null. Thus, in this example, aleph null minus aleph null equals minus aleph null, which is aleph null minus 2 aleph null. This holds for any integers too. Thus, aleph null minus aleph null is between plus minus aleph null. And what about arithmetic of iota, which is 1 over aleph null? And is iota equals iota plus iota equals iota multiplied by n equals 1 over n for any positive natural number n. It is because iota plus iota equals 1 over aleph null plus 1 over aleph null equals 2 over aleph null equals 2 over 2 aleph null equals 1 over aleph null equals iota. And iota multiplied by n equals iota by this calculation, and iota over n equals iota by this calculation. What about iota minus iota? Iota minus iota can be 0, and iota minus iota can be iota by this calculation, and can be minus iota by this calculation. Thus, iota minus iota is between plus minus iota. This arithmetic of iota will be used in the rebuttal of criticism 3 in the next video 3c. Mathematicians may oppose this new arithmetic in this extended number system, which includes infinity aleph null and infinitesimal iota as 1 of aleph null as elements in the system. However, this new arithmetic strictly follows the premise of one-to-one correspondence, and there is no flaw in the reasoning other than the result is against the dogmas in the current mathematics. I also would like to make a note that it differs from non-standard analysis, which is based on transfer principle. Please send critical comments to this address. Thank you very much.